We don't want to take you away from that for too long. All right, so let's go ahead and jump into the quiz. This wasn't too bad. Why are there so many questions? They're probably like all review questions, like the homework quiz was. Okay. So what are the null and alternative hypotheses?
Looks like the third one.
Right to me. Yep.
Because the null is the slope is 0.
Right. Okay. Residual is the difference between
That should be the third one.
Yeah, that's what I was thinking. I was just in the process of reading that. What was that?
Yeah, I think that was the right one.
Okay. A plot of residual supports using linear regression when see a megaphone shape. Residual.
That
one is.
Let's see.
Should be the first one. Kind of what it is. Because the last two are ones for sure that are non.
Yeah. It should be the first one because being normally distributed is going to give it that hot dog shape.
Yeah.
Okay. Yeah, that makes sense. Okay, let's open up math self-efficacy.
Nope. Nobody's over there.
All right. So you guys have the where's that stupid? I just had to. There we go. Oh.
Oh man, you have to fall away from me.
Score variable is the response variable. Okay. Score is the response. Paste.
Scores is X, right?
No, score is Y, the response variable.
Right.
Oh, okay.
So it's Y. Confidence is the X, the explanatory variable.
Okay. That looks right. Okay.
Let's do.
This is explanatory.
All right.
Okay. So I got my graph, and the question is, residuals. Are they linear?
I would say looking at the plot, they're linear.
Yeah, I would say so.
Yeah, I would agree.
Okay. So based on the QQ plot for these residuals, what can you say about these residuals? Fairly normal.
Fairly normal.
Okay, 8. There is a linear relation. The variance error term. I don't know about the second one. Normally distributed. Would it be?
Let's see, we got to do, for the scatter plot, we just click on insert.
Yeah. So I think it's the first and the third, and then is it the second too?
Second, I was thinking the last one.
Fourth, the last one. Well, aren't they dependent?
Oh, I see. Yeah, because they're normally distributed, they'd be dependent.
Yeah.
Okay, gotcha.
Yeah.
So then, yeah, I think the first and the third then.
Okay. Not the fourth.
Well, yeah. Oh, right, because I was thinking the Y value, but okay. Yeah, probably the fourth as well, right? Because if they were measured with error.
We won't see it. Okay. Rick, what do you think? Are you still putting it together?
Well, did you put a scatter plot on there?
Yeah.
All right, so we got 1 and 3 and 4, right?
Yeah,
right.
That's what we were thinking.
Yeah, I think that's what it is.
Okay, perfect. Well, hopefully perfect. What is B1?
I got 18.690.
That's B0.
That's B0. B1 is 12.695.
Oh.
Yeah, you just looked at the wrong wrong row.
12.695. Yeah, got it.
Yeah, it's the slope.
.695.
95% confidence interval for B1. So that's already. It should just
right.
be.
That's the upper and lower bound right there, right? 10.674.
10.674. Yeah.
Yeah.
That's the lower.
6.674. And the upper is 14.715.
Yeah.
Oh, I'm about to be kicked out soon. Okay. Number 12. Evidence of a to make our hypothesis.
So the p-value is super small, so I think we would.
Yeah, we're going to reject the null test because the p-value is less than the significance. Third one down.
Yeah. Okay. So if you reject the null hypothesis, what does it mean?
It means there's sufficient evidence.
Right, to conclude
that the slope
is not 0.
Right, that last one.
Yeah, the last one.
Yeah, is not 0.
Okay.
Okay. Crocodiles. So head length was used to predict body length. That means that the body length is the dependent, right?
Yes, head length is the independent. Body length is the dependent.
Right.
Head length is which one's the dependent?
The body length is the because it says
They're measuring
head
the
length
head,
was used to
body.
predict body length.
Okay, so the body length is dependent on the head length.
Yeah, because they're using the head to predict the body.
All right. So we select the body length as that answer, correct?
Yes.
Okay.
Right.
And now we just need to put that into the data in order to get the margin of error in the upper and lower bounds.
All right, so our body length is the response, the Y.
Yes.
Head is the X. That's an easy one. We just copy and
Yes.
paste the column at the same time. And now I can start the 95% confidence error. B1, so margin of error. So that's where we got to take the confidence interval and divide by 2, correct?
Find the difference between the upper and lower bounds and divide by 2.
Yeah.
Yes.
8. 0.443 if we're rounding up.
Yeah.
What you guys got?
Yeah. 0.443.
Yep.
Okay. And then what'd you get for lower bounds?
Lower bound.
7.218.
7.218.
7.218.
Yep.
Okay.
An upper bound of 8.103.
8.103. Okay. Then what can we say about it?
We're 95% confident that the
Confident.
confidence interval will contain the true value of B1, correct?
Yes, because after the problem is done, there is no probability. It's just is or isn't.
Right. That's that first one, right? That's what we're talking about.
Yeah.
Yeah, I agree. All right.
All right. I'll submit.
Okay.
Submit quiz. Yes, submit. Oh, we missed something. We missed. What did we miss? Oh. So we missed question 6 and question 8.
Okay.
So question 6 is not that they form a linear pattern. So would it be the
Well,
first
they weren't
one,
all
maybe?
negative, though, right? It's like some of them.
Yeah, they weren't all negative, were they? They were some. I'd have to go back.
Yeah, let's see. I don't
All
think
Go back. Oops.
I don't think any of them were negative.
I didn't.
Or wait,
Some of them are, but there's a mix.
yeah, some of them are okay. Yeah,
They seem to meet the parameters of -40 and 25.
Yeah.
So
Gotta be the
the
top.
first one's the answer.
Yep.
Okay. And the other one we missed is question 8. And it just shows that we got
Yes.
0 points. So I don't know.
It's an all or nothing question because it's only worth 1 point.
Yeah. So my guess is that second one's also right. So I know the last one's wrong. And so either we marked one right that's wrong, or the second one is right.
So if the second is true, but wouldn't that mean every time there was a variance between the predicted value and the observed value, that it would be the same every single time? Ooh, which seems unlikely to me.
Yeah, I don't know. I thought I was right on this one, so.
Fair enough. I'll tell you what, I think. Are we sure that X values are measured without error?
Apparently not. Error. Yeah, you might be right. That one, we might need to uncheck that one.
Okay, well, I'll give that a try. And so I'll keep the first and the third checked, because I feel pretty confident that those are.
Yeah, I do too.
Correct. So I'll submit that and see.
Okay, so
number 6.
Well, so when we're talking about the variance of error terms is constant for all values, it basically, if there's no megaphone shape in the residual scatter plot, then the variance of error is constant.
Which we do not have a megaphone shape.
Okay.
So that answer is that the variance of error is correct.
All right, so we want to check off the first 4 then.
Yeah.
Yeah,
let's try that. Okay. And if that's wrong, we know that the fourth one's where we're off, I think.
Okay.
Okay.
Well, I'll go ahead and submit.
Okay, give that a try.
So here in the prep work, the last 2 were ones that they couldn't tell, so we made the assumption that they were measured accurately and precisely.
Yeah. So we got number 6 right now, which makes sense, but we missed 8 again.
So it may be all 5 of them. Because in the prep work, it basically says we can't tell if the X's are fixed and measured without error, so we assume that they are. And the observations are independent, we cannot tell, so we assume that they are.
Okay. Well,
you want me to check the last one and try them all?
Yeah, you could try that. I'm leaning more towards is the first 3, because I don't see how they would be independent, because if there's a line, that means one depends on the other.
All right, so in looking at the cheat sheet, the little 5 assumptions to check, the requirement, X's are known constants, how to check cannot be checked directly. So therefore, so then it says X's should be measured accurately and precisely. Same for observations that are independent, cannot be checked directly. Knowing the value of one of the Y's tells you nothing about the other points.
No, it's fine.
Okay.
I'm going to submit with all 5 selected and see what happens.
Okay.
Nope.
Oh, absolutely.
Yeah.
Still missed number 8.
Okay. So.
Well, the first thing we need to do, we need to record, make sure we know what we did get right.
All right, so Michael, do you have your quiz back open? The second try?
Not yet. I could do that. I was just looking at So I had the first one and then 3 and 4, and then Paul, you did all but the last one.
Right. So now it seems like we need to try the first 3.
Well, I think we know that. Yeah, I don't know. I think it might be the first one and the last 3. Unless we're way off on something. Okay, here I'll. Oh. Hold on, let me get the quiz opened again.
Oh, wait. Okay. So, looking at the prep work, the assumptions that x's are fixed and measured without error and observations are independent cannot be. It says, how do you check? Cannot be checked directly. So that means we can't assume that from the data. So the last 2 need to be unchecked for sure. To me.
Okay. Hold on, let me get all the answers again real quick. 3 was equal and not equal, right? Third one down. 4 was
the third one down.
Difference between the observed value of y. 5 was you see a no. When the looks normally distributed, right? The first one.
Yes. Yep. I'm sorry. 6. Yeah. 5 is the first one. 6 is the first one.
Okay.
7 is the second.
Okay, fairly normal. Okay. 8 is the one that. Okay, so what am I trying for 8?
Okay, so for 8, okay, so here we go. So if there's a hot dog shape, there's a relationship. We see a hot dog shape, right?
Yes.
If there's no megaphone shape, then it's constant. So that box should be checked because I don't see a megaphone.
Right.
And then for the normally distributed, if the points are close to the QQ plot, if they're close to the line, then they're normally distributed. Has anyone made the line?
My QQ plot is not working for whatever reason.
Are you guys going home?
Well, I am. Everyone else is going back.
I have it here. They're kind of close, but not really.
You have the.
What was our first attempt? I don't even remember.
It was.
Wasn't it 1, 3, and 4?
Yes, I think so. Give me 1 second. I have to get out of this room. People are coming to kick me out. So I gotta switch internet connections real quick. So I may lose you for 2 seconds.
All right.
I was looking at this.
Okay.
All right. So I just did the QQ
Lose
plot.
you guys.
I just did the QQ plot, and they're normally distributed. They're near the line.
Okay.
Okay, so I think it's the first 3 boxes then.
Sounds good.
I feel pretty confident about that.
Okay. I'll stake my grade on it.
Yep.
Yeah. At this point, 1 point is, whatever. So what was question 9?
12.695.
12.695.
Yep.
Okay. Question 10.
10.674.
11.
14.715.
715. Okay. 12.
Reject the third one down. Reject the null because P is less than the alpha.
Gotcha.
Yeah.
13.
13 is the
is
last one. Sufficient evidence to conclude the slope of the regression line is not 0.
Right, the last one.
okay. And then 14 is body length, right?
Yep.
15.
0.443.
16.
7.218.
Okay. 17.
17 is 8.103.
And 18 was
Top one. We're
we have a
95%.
90% confidence. Yep. Okay. Here goes nothing. Yep. We got it.
All right.
All right. Let me know when you guys are ready for me to read them off.
I'm very happy you haven't asked a different question.
All those park noises are making me jealous.
That's what's making me jealous that I'm here.
Yeah. All right. Well,
But I've been here a while. It's been fun.
that's good.
All right, I'm ready when you are, Paul.
I'm ready.
Okay. 3 is the third one down. B1 equals 0 and not equals 0. 4 is also the third one down. Observe value Y. The residual looks normal. It's 5. Between 40 and negative 40 and 25 is 6. 7 is they are fairly normal. The residual are fairly normal. 8 is the first 3. 9 is 12.695. 10 is 10.674.
10.674.
Yes.
Okay.
11 is 14.715. 12 is the third one down. Reject the null hypothesis because it's less than. 13 is the last one. Sufficient evidence that it's not 0. 14 body length. 15 is 0.443. 16 is 7.218. 17 is 8.103.
I'm going in my car. Katie's going to drive this one.
Lily, we're leaving. Are you coming?
All right, guys. My phone is dying as we speak, so and I think we're good. Okay.
Hello.
Hi, can you guys hear me?
Got you now.
Okay. Yeah, my phone is dying, so I think we're good.
Yeah. Have you looked at the inference for project for this week?
I haven't, but I'm flying home tomorrow
Okay.
night, and so Wednesday day I have all day to look into it.
All right. Yeah, I think you're the main writer for this one, so
Yeah.
take a peek
So
at it.
I'll try to be prepared before our meeting. We're meeting Wednesday night, right?
Yeah, if we could do Wednesday again, what time do you guys want to do? 8 or 9 Mountain?
8 works better for me, but I could do 9.
I can do 8. That's fine.
Okay. All right.
All right. Sounds
All right,
good.
that sounds great. All right, we'll talk to you Wednesday.
Thanks.
Yep. Bye-bye.
Bye.